Hello students, we are going to study structure of atom, okay, and the topics we will be studying are discovery of electron, protons and neutrons, okay. So first of all, what is atom? Atom in Greek word, it is known as atomino, which means what? Non-divisible. It cannot be divided further, okay. This atomic theory was first given by whom? John Dalton. Okay, so Dalton atomic theory says that matter is made up of indivisible particles called atoms, because at that time electron, protons and neutrons were not discovered. It was said that atom cannot be divided. Okay, now, but later on, right now, at present, we know that atom consists of what? Electron, protons and neutrons. Okay, and these are the subatomic particles of atom. Okay, and these are subatomic particles, but they are the fundamental particles, as they are the main constituents of atoms. Okay, and they play a great role in the reactions. Okay, now, Dalton atomic theory, it could explain all the laws of chemical combinations, like what? The law of conservation of mass, the law of definite proportion, law of multiple proportion, but it failed to explain the electrical nature of matter. Okay, so what happened? Scientists came forward and they started doing the experiments in order to find out the electrical nature of matter. So Faraday, first of all, he studied this electrical discharge in a cathode ray discharge tubes in order to find out this property of what? Electrical nature of matter. Okay, he took a what? Cathode ray discharge tube. Okay, this tube is made up of glass, hard tough glass. Okay, and he took two electrodes, one negative one, named it cathode, positive, named it anode. Okay, this glass tube consisted of a vacuum pump. Okay, and it was connected to the wire. Okay, so here we will be providing electricity. Okay, first he tried to do the experiment in normal condition, in ordinary conditions, but at ordinary conditions these gases are poor conductors of electricity. So what happened? He passed high voltage, okay, and through the vacuum pump he adjusts the pressure and made the pressure low over here. Okay, and now he saw what happened to the gases. He saw that something is moving. Okay, it was observed that something is moving from cathode to anode. Okay, something started moving from cathode to anode, but this is not visible. Okay, for visibility of, for seeing this nature, what happened? This cathode ray tube was painted with a fluorescent substance. Okay, and when it struck this anode, this fluorescent substance got what? Lighted up, and this could explain the character of, or this could explain the behavior of these rays which are coming from the cathode. Okay, so from this experiment he concluded that, what he concluded, that this starts from the cathode and it moves towards anode. Okay, these rays are themselves not visible. Okay, but their behavior can be observed with the help of some material, mainly the fluorescent material, which glows when it is hit by them. Okay, when these rays hit this fluorescent material, okay, what happens? It starts glowing. This is a very good example. There is a very good example of television screen. Initially we used to see what? When we used to switch on, what? The TV screen got lighted up with blue color or green color. That shows the behavior of the cathode rays. Okay, this TV picture tubes, this also works on the function, works on the behavior of this cathode rays only. Okay, Now, in the where there is no electrical, if there is no electrical field or magnetic field present over here, these rays move straight. But if the electrical field is present, suppose if we apply electrical field, this is minus sign, this is plus, this means this is negative and this is positive. We see what the deflection of these rays towards the positive charge. Okay, this proves that these rays are negatively charged, and from here the name came the electrons. Okay, and this happens with the magnetic field also. Okay, north and south, we can see it shows deflections when the magnetic field is present. Okay, now next is they are made up of material particles. Okay, so if I am saying they are made up of material particles, how this was proved that this is made up of what? Material particles. It means what? For that a paddle wheel was fixed over here. Okay, so when the rays started moving from negative to positive, this wheel started moving. It means they are what? Material particles. Okay, now next is they moved in a straight line. How it was proved that it was moving in a straight line? Okay, for that some material was put over here. Okay, and it was seen that it cast shadow over here. This shows that they moved in a what? Straight line. Okay, because if something was, it obstructed them. Okay, and as the result what happened? The shadow was cast. Okay, now next is next point where it is that these cathode rays, they have got what? Heating effect. Okay, and they can ionize from where they pass through. Okay, it can they ionize those particles from where they are passing. Okay, they have got a very high penetrating power. It can penetrate the aluminum sheets also. Okay, all the metal sheets also. Okay, now next is its characteristic feature is it causes fogging in the photographic plates. It also produces X-rays. Okay, when it is struck with what? Copper or tungsten. Okay, these all observations said about the properties of cathode. Okay, and we said that yes, they are negatively charged particles, and so they are known as electrons. So this is how the discovery of electrons took place. Now next, the discovery of protons. Okay, also known as what? Anode rays or the canal rays. Okay, it was discovered by Goldstein experimentally. Okay, in 1886. Okay, so now for this he took what? The same cathode ray tube which was taken in that experiment of electrons. This is made up of what? Hard glass. Okay, but the cathode which was used over here, okay, is what? Perforated in nature. Okay, so now what happened? From the cathode, the negatively charged particles, the electrons, started moving through water anode when he applied high voltage and low pressure. Okay, but he could also see some of the particles moving back of the cathode. This was not understood. Why? Because if these rays are moving, they should move from here to here. It will not move at the back. So when perforations were there, it was seen that something is moving from the back of this cathode also. And when it was seen, okay, it was seen that they are positively charged and they are coming from where? Anode. So they were also known as what? Anode rays. And as these cathode consisted of perforations, okay, and this looked just like what? Canal, and so these rays were known as canal rays. Okay, so now the observation, by making the observation of this particle, he could say about its properties that yes, these anode rays also travel in a straight line like that of cathode rays. Okay, they are also material particles like that of cathode rays. Okay, and here they also showed diffraction in the electric and magnetic field. Okay, as cathode rays showed in this in the discovery of electrons. Okay, but the deflection was in the opposite side. Okay, now here the main difference was that in that cathode ray it didn't depend upon the nature of the gas present in it, in the glass tube. Okay, but here it depends upon the nature of the gas taken in this glass tube. Okay, so now then he found that these are positively charged, gaseous charge, positively charged ions, so named what? Protons. Okay, so if we want to define a proton, it becomes what? Proton is a fundamental particle carrying 1 unit what? Positive charge. And if we are saying 1 unit positive charge, hydrogen has also got what? 1 unit positive charge, so it can be compared with that 1 atom of hydrogen. So this is how these protons were discovered and its properties were found out by the scientist Goldstein. So now the discovery of neutrons. It was discovered by James Chadwick in 1932, which is far later than the electrons and the protons. Okay, he bombarded a foil of what? Beryllium with a fast moving particles. Okay, and then he saw what? Fast moving what? Alpha particles. Okay, and he observed what? That a highly penetrating rays which was consisting of neutral particles were observed. Okay, and he named these neutral particles as neutrons. Okay, and these neutrons did not have any charge, no positive, no negative. It was neutral in nature. Okay, and it was consisting of mass of 1.675 into 10 to the power minus 27 what? Kg. Okay, and this mass is of what? Approximately the mass of 1 atom of what? Hydrogen. Okay, now let us sum up this whole topic of discovery of electron, proton and neutron with the properties of fundamental particles, the basic properties of the fundamental particles, that is the electron, proton and the neutron. Okay, so if we are taking electron, the symbol of electron is small e. Okay, its absolute charge is minus 1.0622 minus 1.6022 into 10 to the power minus 19. Minus here we are writing just to symbolize this electron. While doing the calculation, we will not be writing minus or plus over there. Okay, the relative charge of electron is what? Negative charge of 1. Okay, its mass is how much? It is very less, or it is how much? 9.10939 into 10 to the power minus 31, which is very small value. Okay, and its approximately marks, it becomes negligible, so that is what? 0. Okay, now proton symbol, it is represented at small p. We write plus 1.6022 into 10 to the power minus 19. This can be avoided while doing the calculations. Okay, so positive relative charge is plus 1, and yes, its mass is 1.67262 into 10 to the power minus 27. That is just approximately the mass of 1 atom of what? Hydrogen. Okay, and so here we are saying that its approximately mass is about 1. Okay, now coming to neutron. Neutron symbol is small n. Okay, it doesn't have any charge. It is a neutral particle. Okay, so its absolute charge as well as the relative charge is what? 0. Okay, and the mass, if we say the mass here is what? Is approximately equal to the 1 atom of hydrogen, that is 1.67493 into 10 to the power minus 27. So mass of proton and neutron is nearly the same, and that is what? 1 over here. So okay, so this is all about the electron, proton and neutron, its discovery and its fundamental properties. Okay, or its its properties of what? The electron, proton and neutron. Okay, this is all for today. Good day, take care.